Okay, hello to everybody on the live stream. So this is part 2 of my efforts to explore the latest toy, version 12.0 of Wolfram Language and Mathematica. So about a week ago now, awfully long time, I went through some fraction of what's new in 12.0, and I think I went on for about 3 hours. So we still have a bunch of stuff left to go through. There's a blog post that I wrote that goes through a whole bunch of this stuff, and I'm going to roughly follow what's in the blog post, I think. There's also some really nice examples, actually about 300 examples, I think, that are on this page that you can find from the front page of Wolfram.com. Lots and lots of examples of what's new in Wolfram Language 12. So I thought I would start by talking about our knowledge base. So as people perhaps know, the Wolfram Alpha knowledge base is almost all accessible in Wolfram Language now. And in fact, one of the things that's happened in 12.0 is that we've kind of really tightened up the way that those things can be reached from Wolfram Language. So let me show you what I mean by that. So here we have this notion of entities. Let me see where the best place to go for this is. Okay, here we go. Okay, so what we have is hundreds of different entity types representing all sorts of different kinds of things. Like, for example, let's say, I don't know, universities. So what we can do here is we can say random entity, and we can say something like university, and then we could say like 20 random universities. So this is now going to retrieve the entities associated with 20 random universities. So for example, we could say, let's make a geolist plot of these, show where those 20 random universities are. Okay, they're scattered in different places around the world. We could probably figure out how many entities we know. If we just say entity list of university, we'll actually retrieve all the entities, all the university entities. So let's say unis or something is that. And we can just retrieve a list of all of them. And we could, for example, oh my gosh, there are 27,000 universities that we know about. And these will get downloaded, and there's a pretty efficient caching mechanism for the information, and there's some prefetching of data. But we can do this, and we could, for example, we might be able to say, what could we say? We could say, I wonder what will happen if we were to say something like, let's just say, I don't know, I'm living very dangerously here, but let's just try something like this. This may be hopelessly slow, but what I'm trying here is to say make a geohistogram showing the density. Oh my gosh, this may take too long. This is now downloading information from the cloud about all these different universities, with the intention, if this succeeds, of making a geoplot that will show us the densities of where the most universities are in the world. So while it thinks about that, let's take a look at some of the other kinds of things that we can, the other kinds of entities that we have, the geographic entities, astronomy, things about, I don't know, frequency allocations, or things about artworks. Okay, we can try some of those. Lots of stuff about foods, very detailed information on foods we've been curating for a while, down to food crust types. I kind of wonder what the food crust types are. Various kinds of all sorts of things from physical sciences, linguistics, and so on and so on and so on. Just a big long list of these things. But by the way, people who are wondering how can you try this out, you can always get a trial version of Mathematica, but you can also go to the web, and you can just go to immediate access, and you could try, for example, the development platform. Actually, this is all changing quite soon, but oh, look at that. We actually got the results here. So here we have the sort of histogram of density. Let's try making this. I wonder what happens if I say geo. I wonder if it knows. I wonder if it's cached the data properly. Should have done. Let's see if I can make a smooth histogram. So there we go. Okay, that's kind of cool. So that's showing the density of universities in the world, and it's showing that I guess there's a swath here across. I didn't actually know that. There's a swath of sort of high university density across that part of the US. Kind of interesting. Okay, in any case, I was just going to say that the things I'm doing here, you could also go, if you want to, you can go to the cloud, and you can go and start saying, I could just for fun, I could just say, let's see, let me make this a bit bigger. Let's say 125%. I could do the exact same thing here. Won't be quite as efficient, probably. Let's say random university. I could pick up another 10 random universities here in the cloud, and I could be doing the same kind of computations. There we go. So the same kinds of computations that I'm doing over here on desktop, I could also be doing directly in the cloud in a web browser. All right, so let's go back here. Let's take a look at a few other kinds of things here. I don't know. Let's say we wanted to. There's just a lot of different stuff that you can do, but we're going to talk about a bunch of aspects of this. I mean, I don't know. We could say, gosh, there's so many different things. Pokemon. So we could say, how about this? Let's say random entity. Just for fun, let's say random entity solar system feature. All right, let's get 10 of those. And then, I don't know where these are, but let's say, let us try saying, I really don't know where this thing is. So let's find out. We don't have a mechanism. Okay, we don't have a mechanism to say, let's see what happens if I say geolist plot of this. And with luck, this will be on some solid body that we can show a picture of. Where will it be? You know, one thing we don't have is a thing that asks, what planet is this on? But we should be able to have, I'll tell you what, actually, the best thing to do, forget this for a moment. Well, let's keep that going. I'll tell you what we want to do. We want to just say, let me just ask it, what is the geo position of that thing? And let's see what it does. Aha, okay. Well, that happens to be on IO. Okay, that's amusing. So let's say geolist plot of that, and let's say geo range arrow all, and I don't know. Oh, there we go. Okay, isn't that cool? Okay, so look, there's that particular spot on IO, and we can make this less obscure by saying, okay, well, that's on line 8, so we can make that less obscure by saying geo projection goes to something like orthographic. And then hopefully, there we go. So there it is down at the bottom near the south pole of IO there. You know, we can look at all kinds of things. We could say something like Apollo landing sites. And then that will now go from natural language. Okay, it'll give us this list of landing sites. Let's say we say, actually, I wonder if I can just say geolist plot of that. Let's see. Okay, this will now show us, hopefully, where the Apollo spacecraft landed on the moon. I don't know why this is taking it so long to do that, but let's find out what's happening here. Maybe, okay, hold on. Let's say we say, let's just ask for the geo positions of those. There we go, 6 of them. Great. So now let's say geolist plot. Oh, you know what I want to say? I want to say geo range to all. And to make it less obscure, let me do that same trick with geo projection to orthographic to make it look like the moon we see. I shouldn't have said percent. Should I have said percent? Let's see, percent 12. Oh, what happened there? Let's see what I might want to do. Well, I'll tell you what. Let's see what there may be some something confusing going on here. So let's just ask for the list of all those, and now let's say let's ask it geo position of that, just to check that we've got the right thing going on. Yeah, there we go. Okay, so now what we want to say is geo position of the things on line 15, and then let's see that. Okay, there we go. So there are the positions of the Apollo landing sites, and no doubt we could label them and all those kinds of things. But so this is just I mean, it's just a huge amount of stuff we can do here. I could say, for instance, what else might I pick? I might pick let's pick I'll tell you what, let us pick caves. No, let's pick bridges. Okay, so let's say let's just get a random list of entities, 10 random bridges. Okay, actually, I'm going to do something simpler first. Let me show you how to something that's new that's newly possible is to be able to say I want to get the class of entities, which is countries. Actually, let me just ask for let's say the class of entities that are countries where the population is take largest, let's say 10. So what this will do, what am I doing wrong here? That's what I want to do. Now this will give me, if I say entity list of that, it will show me those countries which have the 10 largest countries by population. And we can kind of unpack this because each one of those countries we could say give that country, we could for example just say entity value of all those countries with population. But what this is doing is it's asking to create a kind of composite entity, which is a composite country entity where we've selected the countries with the 10 largest by population. Okay. And there's just a lot of detail in all of these. I mean, this is many terabytes of data, and that we've collected over the last few decades about all sorts of things. And the thing that's kind of new in version 12, particularly, is the information about is the kind of the way in which you can use these kinds of entities directly in Wolfram Language. Somebody is asking about sources. Let's take a look. Let's say for where did I find universities? Okay, so you go to the page about universities. This is now documentation. There's sample entities. There's properties. There's basic examples. There's a bunch of detail here, and someplace here we should have the information we have. So if you go look, for example, in Wolfram Alpha, we can say, let's say, I don't know, UI UC. So that will give us kind of a lot of information about University of Illinois, and down at the bottom will be sources, and you can go click on that, and it will tell you the sources for all this. So university data here. There's the list of sources for university data that we've used here. So let's see. List of sources as well. This is basically the answer. I think there is a way to do it directly in Wolfram Language, but the easiest way to do it is just go to Wolfram Alpha, look one of these things up, and go to the bottom and click the source link. How do we gather all this information? It's a huge amount of work, and making all this stuff consistent is just, well, it's a huge amount of work. I mean, if let's take, for example, I'm going to live totally dangerously because I have no idea what this is going to do, but let's imagine that I take that feature on IO. I wonder whether this exists. Let's see. If we said like geo elevation data of a geodisk that is I'm completely living dangerously here because I have no idea I don't even know whether geoelevation is known for IO. Has anything mapped the elevation data? It does not know that for IO. I'm sure if we went to something like the landing site for Apollo 16 or something, we could go and we could say, what's the, this is again, getting all this data to be consistent. So we can there's the geoelevation data, we can say, make a plot of that data, and we could hopefully go and say, this, for some reason, something is very strangely slow about a bunch of these. Oh, well, maybe that's the reason, because there's a lot of detail there, and that's it's a big messy lunar surface there. Okay, hopefully the spacecraft landed right in the middle there, right away from all those peaks. We probably see, again, having all this stuff be consistent is a very very non-trivial thing. I mean, if you look at the kinds of domains we've dealt with, they're very, very diverse. I mean, if you geographic data, scientific data, I don't know, what would you, if you tell me what some stuff you'd like to look at, I can, here, let's just try a random entity of an artwork. Again, I might be living very dangerously here, but let's say, okay, so there's 10 random artworks. Let's just take a look at, let's see whether we can get some images of those random artworks, see whether we have those. Okay, so a bunch of those happen to be paintings. We could go and see, who painted those, where they are, all those kinds of things. Or we could do something like, here's a fun thing to try and do. If we say word translation, so pick a word like picture, and now we can say, translate that word into all the languages that we know. So this should give us, boy, something is running really slowly. But anyway, they're okay. So this is the word for picture in a bunch of different languages. So lots and lots of detail. I mean, again, we can go, but what I really wanted to show you was some of the new capabilities that we have to really drill into this data in Wolfram Alpha, in Wolfram Language. I mean, I think if I say something like some of these things we can just do, 10 tallest mountains in Africa. We can just use natural language to synthesize. Yeah, there we go. So what this did was it synthesized the symbolic representation of that. So let's try seeing what this does. So this is now making an entity class. Okay, let's see what happens if we make an entity list from these. Okay, there we go. So this will now show us what this did was we took natural language, we asked 10 tallest mountains in Africa, that translated the natural language into this symbolic query. Then we did the computation based on our knowledge base and got the result for these mountains. Okay, somebody is, let's see. Somebody is asking whether we're yet using around as to express uncertainties and quantities. I think maybe for a few of them, but doing that broadly across our whole system is very non-trivial, and it isn't even clear. When you say what's the well, I don't remember I'd have to. What is the let's see what we know about that mountain, for example. Well, let's just see what properties we know about the mountain. But if I wanted to say what's the correct around value for that mountain, in other words, what's the correct error to assign to the elevation of that mountain? I don't think we know. So it's sort of beyond what one knows about this kind of data. Information about models of vehicles, cars and trucks and so on. Actually, we have that in, if we go to, let me just do this here. If I go to Wolfram Alpha, and I don't know, what's the type of car? BMW X5, for example. So we should have a lot of information here about the BMW X5. We have distribution of, we have all sorts of prices, all kinds of different things here. Gosh, all sorts of things. I guess one of the difficulties with cars. Cars have a fairly complicated ontology because they have many different detailed features. So, for example, these are exterior colors available with different. I don't even know what these are. This is different. I don't know what any of this stuff is. Let's see, a trim comparison. What on earth am I going to get here? That would be, oh, I see. That's a different subcase of that type of car, and that's telling us the engine speed at maximum horsepower. So this data is not yet available in Wolfram Language, but will be. So let's see. Yeah, well, it really helps. We absolutely have the linguistics for car models. We're being asked about interpreter for car models. We absolutely have that. I think we have. I don't think we yet, as I say, we don't yet have that in the language. Let me just show you something. This is how you can sort of do a custom version of that natural language input. So, for example, if I say this is definitely going to be an aircraft, and I say something like, again, I'm going to live really dangerously. I wonder if that's going to work. Not sure if that is going to work. Oh, yes, it is. Okay, so 747, if I were to just type that in, like to Wolfram Alpha, it will say, well, that's probably a number. But if I use the specific interpreter, if I use a specific interpreter for aircraft, then 747 will be interpreted as a Boeing 747. Let's see. Oh, Edmund is asking on the live stream about why not use Wolfram Alpha directly in the notebook. That is a good idea. And you can always do that. You just type double equals here, and now I could type my BMW X5 query here, and it will generate the same output as Wolfram Alpha, but in the notebook, and that's what I should have done. Good. It's always good when and if I wanted to here, I could probably get the computable data from that pod. So let's take a look and see what that does. Well, okay. It doesn't. What that does in that case is it gives me it doesn't quite. That's why this is not yet available directly in the language. That not all that data is exposed. But if I, for example, were to say use the interpreter. Use interpreter for colors. Again, I'm living super dangerously here, but let's see whether that color, which I have never heard of. No, okay, well, maybe that's a special color for BMWs. I'm not sure. Is interpretable as a color. If I said, hot pink or something here, it should actually interpret it as a color in there. So, a person whose name I can't pronounce on the live stream is saying it seems there are more entities available in Wolfram Alpha comparison to Wolfram Language. That is correct, because the standards for kind of having things be computable are a bit lower in Wolfram Alpha. They're still very high in Wolfram Alpha, but they're a bit lower than they are in Wolfram Language. I mean, just to riff on that for 1 second, one thing I mentioned, I showed a nice little plot at one point here. When we released our data repository, and let's see, I think I had this kind of chart which sort of showed levels of making data computable. Is your data arranged in a structured way? Are the standard entities in the canonical symbolic form? Are the data values uniformly consistent, et cetera, et cetera, et cetera? And we have to reach about level 9 to get into Wolfram Alpha, but we have to reach level 10 to get into Wolfram Language. Because we need a level of consistency, because I can go and do things like, for example, that thing I did with universities earlier. We better know with pretty good accuracy where all the universities in the world are, or we're going to get a stupid result for this plot. So that's a higher level, whereas in Wolfram Alpha, what you're primarily doing is saying, tell me about this particular university. Let's see. Okay, let me keep going here. I want to talk about new things in version 12 related to data. So sort of the big the exposure of all of this data directly in the language uh, is significant, and you know, you can do a lot of kinds of things where you're using, I don't know, let's say we say something like I don't know, let's say London, and we could say what's the population of London. Okay, we can then say here we can go in and we can just symbolically represent um, the well, if I say dated and then I say something like 1970, um, then I will get. Actually, I'm curious. I have to do this. I'm sorry. Um, let's do this. Excuse me for trying this. Uh, okay, interesting. All right. Um, I happen to be born in London. But we could also say, give us all the uh, give us all the data points you have, and then we could make a date list plot and so on. But the point is that we're able to go in and sort of fluidly deal with all these different kinds of entities directly in the language. Okay, now let's talk about a big and complicated other area. All right, what and that has to do with, we've got uh, lots and lots of domains of data that we have already built into Wolfram Language. But what if you've got your own data? Can you make your data kind of act like the data that's in Wolfram Language? Well, the answer is, to a large extent, yes. And let me show you how that works. So let me show you as an example. Let's see here. Oh, okay, well, there we go, actually. What I was going to do, that's actually the first, what I was going to do is show you in our data repository, there are there's data that's available in data sets. So for example, if I pick up, I don't know, a random one of these, let's say transportation, New York City motor vehicle. My gosh, what on earth is that? That is really weird. Well, that worked. That was really weird. What happened there? So let's say, for example, we have we go click on that. We say, give me resource data about New York City elevators. It's now going to download 12 megabytes of stuff about New York City elevators, and it will now come out as a data set. And we can then query that data set and do okay, so this is lots of detail about elevators in New York City. Now notice, this data is not nearly as clean as the data that is directly built into Wolfram Language. So for example, here with this street name, you know, we would be having to deal with, you know, East 14th Street. Okay, we can say, find geolocation of, we could go ahead and pull that out, you know, find geolocation of whatever that was, 93 address number. So this is all a bit of a mess. You know, we don't have, I suspect here, a pure geoposition. We can say, let's try this, East 4th Street. Let's just try this. I don't know whether this will work, but we can try actually doing the geo lookup. There we go. So that actually did find a geo position, but this data set, which has 76,000 rows, this is much more raw data. It has not been curated to the point that we would put this into even Wolfram Alpha, let alone Wolfram Language. But still, when you actually want to do computations here, you can absolutely do things and figure out, I don't know, I mean, of those 76,000, I mean, I'm just curious here. Let's just do a counts of, well, let's do a line 43. It looked like there was a thing over there called, what was it called? It was called type. And so we can say all comma type, and that will now tell us, okay, there are a lot of dumbwaiters there. Okay, let's see what happens if I just say counts on that. Okay, so that just summarized the different types of elevators that exist in New York City, 66,000 passenger elevators, et cetera, et cetera, et cetera. I can probably say pie chart of that chart labels. Let's try this. See what happens if I do that. Okay, there we go. So now I just did. I just took that data, and you can see most of them are passenger elevators. But this is not nearly as well curated as the kind of thing you'd find in Wolfram Language. Okay, so that's a regular data set. Let me show you what an entity store looks like. So an entity store is something that has a lot more detail. Let me show you this. So this is now going to be an entity store, and an entity store has entities very much like. So here, if I say entity register, I will register these entities. And now there's a new type of entity, which is an SW library book. So this happens to be an entity store of books in my personal library. So if I say random entity, and now I've got, in addition to satellites, I could say, show me 10 random satellites, but I could also say, show me, because I just register, I have this as an entity store, and I just registered that entity store, I could say, show me 10 random SW library books. Okay, so these are now 10 random books. And for example, I could say, and I guess those are the titles of them, which is what it's displaying by default. Let's pick out this one here, and let's say, what do you know about this book? So let's say, I think we can just do that. We can say, okay, show me a data set of that book. But I could also, we could also say, take this entity, which is now one of a custom built entity, and we could say here, show me that result. Show me for that entity, show me something like the year. Okay, now I'm going to live dangerously just for once, because I'm really curious. If I say entity, SW library book, and then I say, let's just say year, arrow, take smallest 10. I wonder whether this will work. Okay, so now let's say entity list of that. Oh, fascinating. Okay, so these are the oldest books by publication year in my library. So if I say entity, value of those books, comma, and then I say comma year, it will tell me the years for those books in my library. And actually now I am curious, because I this is very bad. I shouldn't be doing this here, but I'm just curious what happens if I say SW library book, and then I just say year here, and then I say date histogram of that. So what I should be doing, if this works, is to retrieve, oh, look at that. Isn't that cool? Okay, so that is a histogram of the ages of books in my library, and that's probably when my wife convinced me that we were absolutely running out of space and I couldn't buy any more books. So someone is asking, how do we make sure that all the data we have in Wolfram Language is up to date? It's a big job, but some data is sort of naturally kept up to date. I mean, if we say earthquake data for, I don't know, let's say, Kyoto or something, if we ask for that, then it should give us the most recent earthquakes. Why is this acting so slow? Okay, there we go. Oh, wow. Okay. Oh, this was non-trivial. All right. So we had, actually notice what this looks like. This is a list of earthquakes, 316 earthquakes that it knows about for the that were around Kyoto. And so, for example, if we look at that particular earthquake, we can, I don't know what we could do here. We could say something like, what will we do here? We would say for each of these earthquakes, we want the position. So we could say, for example, for that earthquake, we could ask about, we could ask for a geoposition of that. We could ask for the position of that earthquake. We get the geoposition. So the earthquake feed comes in every second. So we could probably ask, if we go to Wolfram Alpha, well, here, since I just remember the trick here that we can get that just directly in a notebook. So this is now going to be loading in data that is, up to the second data on, I hope, on earthquakes. There we go. Okay, so there was the most recent earthquakes that happened. There was one over there. Where was that? So that was that. There was an earthquake that happened around 4 p.m. of magnitude, about magnitude 6. That was in, it was a 6.4 in the Philippines 19 hours ago, and so on. So this is so something like the earthquake feed, that's always coming in. Something like, I don't know, the financial data feed. I mean, if I say price of, let's say, Microsoft, then we'll get the most recent price quote for Microsoft, their Microsoft stock, and again, that's a real-time feed. But something like the height of a mountain, well, that's pretty much a one-time thing, or the properties of a polyhedron, that better be a one-time thing, or something like, I don't know, if we look at movies, for example, we'll be getting a continuous stream of data about the movies that are coming out and their box office performance and all those kinds of things. Okay, so in any case, the thing that I was really talking about here is making your own entity store, and I could perhaps show you for what's, maybe I shouldn't do that. What's inside an entity store? It's basically a list of entities and then a list of values for properties of entities and so on. But the big point and the thing that's new is the ability to just take an entity store that I just created myself and do all these nice operations that we can do on built-in entity stores. Now, the one downside of an entity store that I create myself is all this natural language linguistics that we can do for the built-in entity stores. That's obviously not been built for something that I just created myself. You can start adding a little bit of that stuff, and in the future you'll probably be able to add a lot more. When you have to kind of know what you're naming the various properties in your entity store to be able to use it. Okay, so the next big question is probably, okay, what if my entity store is really, what if I want to use as an entity store some giant external database? Okay, so there's a big new thing in version 12 is the ability to connect to an external database. And so now let me give you an example of that. So this is, I'm just going to connect to, so, okay, what we have in version 12 is really, I would say, very powerful ability to sort of specify symbolically what you want from an external SQL type database. And I'll talk also later about graph databases. But for now, let's talk about SQL databases. And in technical terms, what we've built is a kind of symbolic ORM. But what this is here, so this will now connect. This is a very simple SQLite database that's a file-based database, but we'll connect to some bigger databases later here. So what this is doing is it's saying this is a symbolically represented relational database, and it has certain, these are the tables. Each table is essentially an entity type. So for example, I could say here, let's see what I have to do here. I have to go ahead and I have to say, first of all, I want to make this into an entity store. I want to take that relational database and turn that into an entity store. And then I'm going to go even beyond that. Okay, so there's my entity store that's been created. Then what I want to do is I want to say entity register that. And so what that's going to do is it's going to register all those tables in the database as entity types. So for example, if I say here, entity list of offices, that will give me that's a very uninteresting keys. But anyway, that will give me the list of primary keys in the table offices in that database. So for example, here I should be able to say, show me the properties for that entity of that entity type that came from this external database. Okay. So now I could say something like, I could do the exact same thing that I did before. I could say, for example, I have an example here with the payments table in this database. I could say, show me the payments with the 10 largest, payments. And these are, as you can see, these primary keys for these things are pretty awful. But that's what was in the database. This is simply interpreting what was in the database. We could have remapped it when we built the entity store around this, but I didn't do that here. And so, for example, if I ask what are the properties here, we would have, I don't know, that was an amount. So we could probably say, we could go ahead and we could say something like, what could we do here? We could say entity value of payments, and then we could say amount, and then we could do our little histogram thing again. And with luck, we will now see, okay, so that's from this database, that's the distribution of payment amounts from the database. Now, the thing that is really important about all of this is that we can do operations where we specify them symbolically here, but they're actually taking place in the external database. So I may be able to do that with a big database here. Let me take a look here. I think there is a decent chance that, oh, wow, yes, cool. Okay, let me show you this. Okay, so I've got the OpenStreetMap complete database. This is about I think this is a terabyte-sized database. And what I can do here is I can say, okay, connect to this database. Hopefully that will work here. Why is this so slow? I just, okay. Oh, already exists. That's because I already just ran this just before I pulled it over to the side. So, okay, so what we've got there, and actually what I really should do here is, actually, you know what I'm going to do? I'm going to quit and show you this absolutely from scratch. And I'm going to show you what happens here. So now this is a database absolutely from the wild. This is the OpenStreetMap database, and I'm going to show you what happens if I try and load it in. Oh, that was nice. I thought it was going to give me a bunch of errors because, oh, maybe it is going to give me a bunch of errors because, like many databases in the wild, this database is not perfectly structured. So if I say entity register, okay, here we go. The entity type box grid underscore polygon doesn't have a canonical name because the corresponding database table doesn't have a primary key constraint. Okay, whatever. So in other words, this is reflecting the fact that the external terabyte-sized database is not perfectly clean. But let's say I say, gosh, this is going to get a little complicated, and I'm not sure in how much detail I'm going to go over this. The big idea for these external databases is the notion that we can do things like this. We can say, make a filtered entity class, and this is kind of like a select statement in SQL, a filtered entity class where we're using the entity function. Let's say I don't want to do that one. I want to do Wolfie. Where what we're saying is we're going to make an entity function where we're going to apply to possible entities this function string contains Q, and I'm going to say Wolfie, and I'm going to say, I don't know why I'm saying ignore case, but I will say, no, let's not ignore case. I'm not going to ignore case. And then what I'm doing here, let's start it running. What I am doing, I don't know what that 2 is doing there. What is that 2 doing there? Why would I want to do that? That's just silly. Sorry, I'm just going to, no, I don't want to do that. I'm going to, that's just going to show me, okay, so this is running against this 1 terabyte database. It's running in the external database server, and it's going through and doing this computation. It's compiled that computation to SQL, so it's running in the external server. Okay, there we go. So, okay. Oh, look, Wolffield Lane and Wolfie's Track. But actually, I want to just live a little bit more. Let's go ahead and do this. Let's just say entity value of that. And I think I can just go ahead and say this. Let's see what happens. This may be a disaster. Let's see. question here. Oh wow, those are the only things in the world that are streets whose name starts with Wolfie. Well, who knew? All right, I'm kind of have to. I'm just this will be a big long list, I'm sure, of all the wolf things in the world. Okay, so but the main point here, the main important point is, okay, so there are 23,000 of those. But notice that was a pretty decently fast query. And I could probably take those things and let's see whether, oh, I was just asking the name here. We should have asked the actual entities. If I'd asked the filtered entity class there, and then I could have started going and finding geolocations and all those kinds of good things. But that was a decently fast query against a big data set. Okay. So anyway, the thing, one thing I might be able to show you. Okay, so all of our internal data you can also deal with using the same sort of syntax here. So for example, I could say, give me an aggregated entity class that is of the elements with atomic mass. And so this is now aggregating the elements across periods in the periodic table, taking the mean atomic mass. And now this is then computing. Okay, so we could take this, and this will now give us, okay, so this aggregated entity class, that doesn't really, that's just a purely symbolic thing. And now we could say here atomic mass, and then this will give us this should give us, using our internal knowledge base, exact same syntax as if this was querying some giant external database. This is querying our internal curated knowledge base, and this is now computing these mean atomic masses there. Okay, so just to get a little bit more technical for a second, I think I could show you what the actual SQL looks like that is underneath all this stuff. Let me see if I can do that. I think I have information about how to do it. We will have some functions for doing this, but I'm just gonna do an internal hack here to just show you that stuff. This is and so here I should be able to show you. Boy, this may be a disaster, but let's try it anyway. Let's see this. Okay, so what this should be showing me, hopefully. Oh, come now. I thought this would be echoing the SQL query, and maybe it will take, oh, there we go. Okay, so that wasn't terribly complicated. That was just to select from whatever, where, whatever. But the point is that this, oh, actually, I guess this is using, that's translating the string contains Q to this and so on. In more complicated cases, the synthesized SQL can get really complicated. And what we're doing is we're synthesizing custom SQL, and we're optimizing the query for a whole variety of different kinds of databases. So I think this is an important thing in terms of practical use of Wolfram Language for large-scale data science. Let's see, a question from Edmund on the live stream. Is there a way to pick a prefix for the entity store? In other words, so if you're connecting to more than one database which have tables with the same name, the answer is definitely yes. And I think it will, I forget exactly how to do it, but there is definitely a way to do it. I think if we look up entity store, it will tell us how to do that. There's a way, yeah, by mapping table names in the database specified to type specified by the yeah, so there's a mapping mechanism in entity store to say how to remap the table names. I think let's see. So then let's see. Comment that it would be great if it automatically took care of all bracelet and parenthesis matching. Actually, we have some very nice stuff coming in 12.1 for that. That will be big enhancement. It's really hard to have that stuff really work smoothly. It takes a lot of effort and a lot of testing, but we're working on it. Okay, all right, let me turn now. So I talked a little bit about SQL databases and accessing large-scale data in that way. Another thing that has come in version 12 is RDF, and again, this is a bit kind of technical databasey stuff, is graph databases, and particularly RDF and Sparkle capabilities. So if we go, let's see, if we look at, we have things like RDF triples and so on, and we can represent IRIs, all those kinds of things. So this is a package graph store. Let's move it over here so we keep it in the same notebook. We say needs graph store, and then we're off and running. And here, gosh, what is this? This is I just picked this random example. This is an RDF triple representing something from example.org for Albert Einstein, and this is some schema specification and so on. I think I have an example here. So again, just like you can access our internal knowledge base using SQL-like, SQL-inspired syntax, so also you can access our internal our knowledge base using Sparkle-inspired syntax. So here, this is a Sparkle select of the RDF triple that is United States, capital city, and then a variable. So the way Sparkle works, what it's trying to do is it's doing essentially a pattern match that says in this graph database, when is there a triple United States, capital city, and X? Okay, so we can go and say, let's do the selection there, and then it says United States capital city, and then the third thing in the triple would then be Washington, and now we're getting that result. Okay, so we can try. I see some other examples here that are, let's see. So these are examples that I guess they don't paste like this, but anyway, these are examples where we're saying something slightly more complicated. This is a slightly more complicated kind of query. This is saying what properties relate the United States and Mexico in our knowledge base. Okay, no, actually, I'm sorry. What I'm asking here is what countries appear. No, what am I asking? I'm asking what properties connect the US and Mexico in our knowledge base. And so actually this may be a kind of a complicated thing to answer, because we're asking kind of in what way are the United States and Mexico related? There we go. Okay, so now this ran a Sparkle query against our knowledge base, our whole knowledge base, terabytes of stuff. And what that says is that in our knowledge base, the US and Mexico are related because they're bordering, they're export partners, and they're import partners. Okay, so we'll probably package this Sparkle stuff in a slightly higher level way eventually, but this is what you can do with it now against our built-in knowledge base. Now, if you have a Sparkle endpoint in the outside world, you can then, like, for example, Wikidata is an example of such a thing. You can do all kinds of queries directly in the language using that Sparkle endpoint. So, and here, just one more example. This is just another type of query that you can do. Let's see what we can do here. This is a type of query. Again, I don't know quite how complicated this is going to be. This is asking what sequence, this is an SQL property path, what sequence of bordering countries do you need to go through to get from Portugal to Germany? Okay, so that's now going to run, oh, that's weird. That's just asking, is there a sequence of countries? I wonder whether we can do, I don't know how we do this. See, this is, unfortunately, my lack of knowledge of Sparkle means I don't really know how to do this, but we can just try, just for the heck of it. This may be unsuccessful, but let's see. No, unsuccessful. Okay, I don't know how to use Sparkle well enough. Eventually, we will package this kind of graph query as something that can be done fully integrated into all other aspects of querying the knowledge base. But anyway, so that's just another way in which you can access large scale data from within Wolfram Language. Okay. Well, let's talk about. Let's see. Let me turn to a completely different area, and then I'm going to loop back to. Let's talk about something kind of in our sort of core world, which is nonlinear finite element analysis. So what we have been slowly building up our capabilities in the area of in the area of solving partial differential equations, and in version 12 we now have the ability to do nonlinear finite element analysis, which is kind of a sort of something that's it's kind of high up on the stack of difficulty of things to do. So here, what on earth is that? We should not need that. Let me go ahead and, okay, so what I'm going to do here is, first of all, let me just get, so first thing I have to do is get a partial differential equation to solve. Okay, so here's a nasty partial differential equation that is, I think it's the equation for a soap film. Okay, so let us go ahead and, again, we're going to make something complicated. We're going to say, okay, so there's a boundary condition. And now what I want to do is, let me make this, let's see what happens if we do this. If we make the region that this thing is being solved in a pentagon. Okay, so what this should do, if it works, is to solve the equation for a soap film inside a pentagon with kind of wavy boundary conditions here. So now let's make a 3D plot of this. So we have to say, take that interpolating function at the point xy and do this in, I'm going to plot this over a pentagon. So regular polygon pentagon here. And now just to make it look nicer, let's say mesh functions is like this. Okay, so let's see what this does. Okay, that was pretty cool. So what that is doing, okay, so there we go. So what that's doing is it's solving the equations for a soap film that has been suspended. If we look from above, we should see, in fact, if I were to do, let me do a different plotting scheme here. Let me just say, let's do a relief plot. Yeah, I think that will, no, what I want to do is just a contour plot. And I need to remember it's the line before last. So, okay, so this is now showing us the nonlinear, the solution to that nonlinear PDE over a domain corresponding to a pentagon for this. This is a big deal. A lot of stuff has to work to make this kind of thing operate. Okay, so another big area that was new in version 12 is numerical optimization. And nonlinear, particularly convex optimization. So, for example, here, if I look at what we have in the way of convex optimization, again, it's a bit technical, but it's very this is powerful stuff. All these different forms of all these different types of optimization problem that can be solved efficiently. And if we do something like well, if we do quadratic optimization, okay, so let's do this. Let's say we just we're solving that polynomial. Let me let me just do something oh, I'm sorry. I'm just looking at the questions on the live stream from Schrodinger. Why not have a defined function that outputs the SQL query? Yeah, we will have things that output the SQL query. The problem is that there's some wrapping that's needed around the query in some cases, and some other complexity, and it will be more like our embed code mechanism The embed code mechanism gives you kind of the thing to plop into an external system to be able to do something in that external system. Okay, but back to optimization here. I don't know what I could do here. Maybe I could try making a random polynomial, or I could try, let me see here what I can do. Hold on one second. Let me see if I can pull in something, a good big example, because this quadratic optimization problem, that's pretty easy. That's pretty small. We could even solve that exact same problem with nminimize has been able to solve that kind of problem. Nowadays, nminimize, oops, I want to package it differently here because nminimize is expecting a general expression, so we have to do that. So nminimize will use fancy quadratic optimization if it is a problem that for which quadratic optimization is relevant. Nminimize also, if I were to put in something crazy like this, oops, that's not what I wanted. I just wanted lowercase x there. Oh my God, caps lock on. If I do something like this, oh well, okay, sorry, it didn't make a. Okay, let's put in something to make it more complicated. But I think this will at least guarantee that it's a real number. Failed to converge. Okay, it's unbounded. Well, silly me. I don't know. Let's try that. Okay. Well, that was a really horribly nonlinear thing. But in the case, and there are many practical examples of this, where what the function that one has is a convex function, there are vastly more efficient techniques, and those are things we've now implemented in the language. So let me show you. Maybe I can show you one example of a more sophisticated version of this. Let's see. Let me show you an example of something. Okay, let's see what we have here. These examples are complicated. Well, I'm going to just illustrate for you. This was an example about truss design. This is, again, it's a complicated example. Often the setup of these problems is comparatively complicated. Which actually brings me to another important topic. This is something that we've been gradually developing over the course of version 11, is the ability to represent systems engineering systems and derive equations from them. So just to give you an example of a place where we can get sort of equations from, I could, let's just try this. I can just pull up the system model examples here, and or I could go to documentation and I can find many more of these. But this is sort of real. This is kind of a modeling environment for dealing with sophisticated systems represented by, in this case, represented by differential algebraic equations. So I don't know. Somebody was asking about automotive stuff. So let's do a seat suspension. Okay. So let's try. Let's try copying that model. And this will be now a model, and this is now a Wolfram Language symbolic expression. And I could, for example, say system model plot, and that will make sort of a default plot of this of solving the equations for this model. So now it's going to do some fairly sophisticated things involving doing just-in-time compilation and so on. Okay, that's what apparently happens with the default parameters here to this seat. Now, if we were to take this and we were to say, show me the actual equations, and this is about sort of how one constructs models. So I think I can say system equations, and this will now generate for me, okay, so here are the actual underlying differential equations that were being solved when we did that simulation. And so this whole mechanism of being able to create these sort of block diagram visual representations of systems engineering systems, and then be able to derive from that equations that can be solved to understand their behavior. Okay, but in any case, in the case of nonlinear optimization, we are now able to do very industrial strength kinds of problems. I wonder if there's at least one example that I can show you here. Let's see if this one is simpler. All right. Oh boy, this has some complicated function in it. That's no fun. This is something for, apparently, for laying out. So this is using nonlinear optimization. This is something for laying out a floor plan. Let's see what happens here if I try this. So apparently this is for this looks too complicated for me to do right now. This is given some constraints. This is then optimizing the area and so on. Let me not do this here. Okay, bad idea. All right, I got to do at least one real thing. Otherwise, you guys are not going to believe me that this is really industrial strength. I'm going to do one thing, and then let us just try. I'm going to make random polynomials. So that there's the form, but I'm going to, instead of doing that, I am going to say, make a, boy, we live dangerously here. All right, let's do this. Let's make a random matrix let's make a random 100 by 100 matrix. And let's make each number be between -10 and 10. And so this is a random 100 by 100 matrix. And now let me make that, this is a bad idea. This is just I can easily make a linear problem this way. It's a little harder for me to make a nonlinear problem this way. Let me try this yourselves on big industrial strength problems. Gosh, somebody is asking here, does NDSolve only use Lagrange elements for FEM, or are there plans to support other families of finite elements? Well, I don't actually have the slightest idea, but let's take a look at, let's just see what happens if I were to look at, okay, so this is, in a little bit more detail, the what we have. So solving partial differential equations with the finite element method. So this is a pretty long tutorial about how to do all these kinds of things. I'm afraid I don't know. Okay, so this is showing a lot of different aspects of this. I think maybe even there's more with nonlinear variable coefficients. Okay, so this is beyond my level of knowledge about how these things work. But now, if we want to know the answer to okay, systems of PDEs, all kinds of things here, there's pretty rich capabilities. Now, a question that came up was specifically about Lagrange elements, other families of finite elements. So honestly, I just don't know the answer. I'm sorry. We are going to be doing a series of live streams about particular areas, about 50 live streams actually, about different specific areas of Vision 12 functionality, and there'll definitely be one about nonlinear finite elements, and it will be given by the lead developer of nonlinear finite elements, who will know the answer to your question. I'm afraid I do not. Question from Edmund here is whether PDFs of survival functions and so on will benefit from new optimizations. I think the answer to that is yes. I think that's all been hooked up, because I think that's using the nminimize tool chain basically. All right, let's go to another topic here. Okay, so another big thing in terms of efficiency of our system is our new compiler, and this is a kind of a big story. Let me go and start showing you some things about this. So what we've had a compiler. In fact, I wrote the original version of it back nearly 30 years ago now. We've had a just-in-time compiler that compiles things for numerical operations and so on. This is now a much more complete compiler for Wolfram Language, and it's also a nice modern compiler, it uses LLVM, low-level virtual machine, to represent output. So, for example, here I just said, and now we have this. You can think of being the typed lambda calculus. This is a pure functional lambda expression, and this is a typed one with the type integer 64. And I'm saying compile this function that just computes x squared with type integer 64 there. Okay. Now, if I wanted to, I could say here, I could say, if you really want to know sort of the entrails inside this thing, I could say function compile export string, and this will now show me the LLVM code that is generated from that compilation. And what's more interesting than that is I could say LLVM export library here. Instead of export string, I could say export library, and that will generate a I need to say, what do I need to say here? What are the possibilities? This will actually generate the code for example, let's just generate the code for a Windows machine. This will now generate a library, hopefully, that I could then just use. Oh, come now. Oh, I need to give it the path. Sorry. I need to, I did the wrong thing here completely. Never mind, I did the wrong thing. So if I were to give it here something or other xxx.dll, it will now generate, yes, it will now generate a DLL file that is a binary file that is a library that can now just be loaded in. Let's see, I'm being mentioned that our developer talks start on April 30th with asymptotics, and then next week we start up with complex visualization and I think 50 other topics. So okay, so all the things that I'm talking about, there'll be much more detail there. But this is, to use that function, you would say library function load. This is allowing one to basically take Wolfram Language code and actually install it as a compiled library in external programs. So it's kind of a big deal. Now, what can we compile? Well, in version, I consider the version of the compiler in version 12.0 sort of experimental and incomplete, but we can start to do all kinds of compilations. So this is compiling a Fibonacci function, and so this has got to compile. And no doubt, if I run this thing on, let's say, 10 or something, it will very quickly give me that answer. It'll be quite fast compared to standard code here. And if I wanted to, I could say for this, I could try and just see how complicated the LLVM code that it generated for that Fibonacci function is. So I could say function compile export string, and now it will generate LLVM code. Okay, it's amazingly simple. How could it be so simple? What is it doing here? Well, maybe it is that simple. Okay, it's cool. Tail, who knows? I guess it is that simple. I wonder what happens if I just, for the heck of it, I put in some weird thing here to the power x plus, some long number here, just to see how that works. So somewhere here, there better be a version of that long number, because otherwise something has gone wrong. Well, I'm a little confused about what's going on here, but anyway, the main point is we're able to compile a function like that. Now, again, I'm not going to go into this in tremendous detail, but we are, if sometimes you can't compile everything, and so you have to call back into the actual main Wolfram engine, and so you do that using kernel function, which is something that a kernel function, which is a way of calling back into the Wolfram engine from inside compiled code. So you can expect a lot of exciting things from this compiled code, whether it's just deploying directly in external programs, whether it's even deploying in websites as using WebAssembly, all kinds of fun things like that. So that's kind of a big coming attraction, and there are all kinds of different. There's a kind of, when you want to specify things in this detailed way with type specifications and so on, there's a whole world of different. And so, for example, there's lists of compiled types, and there's constructors for compiled types, and so on. So, okay. Well, let's talk about, I think last time I did talk a little bit about calling other languages from Wolfram Language. And so, for example, I could say, let's do an example here. Let's say, if I want to compute something in Python, I could say something like, 100. What's to the power of in Python? I don't know. It's 1, 2, 3 to the power of 3 or something. I think is that right? I don't know. Okay, so that comes back as a number here. I think we can even deal with does Python. I don't know what it does here, but anyway, I think we can deal with all sorts of different data types here. I think I actually have no idea, but is this going to do something useful? No. I don't know. Does Python have a range, just like we have a range function? I think yes. Oh, but it has 0 origin. I think Guido van Rossum knew Mathematica before he did Python. So convergent evolution is not necessarily convergent. But in any case, one of the things we can also do is to say things like, from within, I wonder whether that works here, from within this Python cell, we can use this notation, something like this, to say, compute something here. Let's compute, I think this will work. Let's say the 10,000th prime. So that's then calling back into Wolfram Language. And if we wanted to, we could do that programmatically with external evaluate and so on. But this is about calling into Wolfram Language from calling into Wolfram Language from an external language. By the way, somebody is asking about other languages. Is Julia supported? I think there is some Julia support available. I think the next one that's going to be available probably in a few weeks is Haskell. It's also things like JavaScript are available, and we will have a whole bunch of languages are becoming available. If they're callable through the Jupyter connector, then they can be reached. The main issue is the main issue with all these languages is the whole conversion of data types, and what happens if there's an image and things like this. That's really the place where there's much more complexity. Okay, but so that's calling to an external language from within Wolfram Language. And I think we can call, let's try this. Let's try something here. I think we can call an external function, like, for example, let's say we call the Python range function. See, I'm really living dangerously here. I don't know if this is going to work, but I think that will work. Oh yeah, there we go. Beautiful. So we can basically just call a Python function just like it's a built-in function, and we can make that into a lambda and things like this. Okay, so of course, if the data types that are being returned here, I think the native Python types we can deal with. We can deal with some of these pandas things and stuff like that as well. Those come back, I think, as data sets in Wolfram Language. Okay, but that's calling out to Python, for example, from within Wolfram Language. What about the other way around? Well, we have that capability also. And so, for example, if we go, let's see, here we go. Let's go here. If we look at, let's go to developer resources. That's always a good place to go for things like this. And we go, we look at deployment channels here. We will get the Wolfram client library for Python. And again, there'll probably be some other talks about this that will go into a lot more detail. And I also don't know Python fluently, so I'm a really bad person to demo this. But what we should be able to do, what happens if we do this? Would this work? Okay, I'm going to try something totally crazy, which may be completely stupid. But let's see what happens if I just put into a Python cell here. Is that going to work? Let's see whether this works. This may be really a stupid idea, but I'm going to try it anyway. So I think what I'm doing is I'm using our notebook to let's see what this does. So it goes. Well, maybe I need to do. I think I would have that and install. This is what happens when you're not just inside Wolfram Language. There's all kinds of weird installation stuff. But anyway, so it goes. Let me show you how this works. So from within Python here, we're just calling Wolfram Language code. So WLExpert, a range of 5, will compute range of 5 using the Wolfram engine. It can either be a local Wolfram engine or it can be a Wolfram engine in the cloud. So you can be running a Python program and you can be calling out to the cloud and evaluating Wolfram Language code there and getting the results back. So there's a Lambda, or there's a pandas data frame thing. That's what's possible there. So a lot of different stuff of dealing with constructing, taking symbolic Wolfram Language expressions, being able to construct expressions that can then be fed to Python and evaluated there. So this is kind of in the nature of how do you if you've written a bunch of things in Wolfram Language and you need to embed them in an external system, this is about how you do that. And in addition to a Python client library, there's a Java client library that will be ready soon. So let's see. Someone was asking about the version 12 spiky. I think the version 12 spiky exists. I mean, it's out and about. I think you can find it on, if you just go look at the maybe I may have to go. I'll tell you what. Let's see. If I start Mathematica, then we should be seeing. Oh well, there's almost the version 12 spiky, although it's just a corner of it. Okay. So question here is: are there new options for deploying solutions? Have there been updates to Cloud Deploy to make it easier to deliver solutions? Well, sure. I mean, there's if you can make an API easily in Cloud Deploy, some things that have happened in Cloud. I mean, there's a lot of detail in Cloud Deploy. So for example, I might say, let's just take, for example, let's say I'm doing something at the notebook level. Let's say I make a let's imagine, what have I got back here? What can I do that's really something fancier? No, I don't know. This is probably going to be too fancy there. So let's not do that. Let's say let's just Cloud Deploy a graphics of a polygon, regular polygon. There's not going to be that exciting, but let's say an n-sided regular polygon. N goes from 1 to 100. So this will be a standard. What am I doing? Oh, there's no polygon with side 1. So this will be a standard little manipulate here. What just happened? There we go. A standard little manipulate. And now I can say, if I want to, I could say cloud publish that manipulate, and then I will get a cloud object here. And then if I go to my web browser, actually just to be more sort of extreme, let's say I say URL shorten, and oops, that's what I wanted. I just want URL shorten of that. Sorry, wait a minute. Okay, so now actually just to be exotic here, I could just say, make a barcode image of that if you guys want to try it. Just to prove this is working, you should be able to go to that barcode image. But now let me just go to my web browser, and let's go there, and let me start an incognito window, so I don't have any cookies or anything. And now, oh, whoops, I need to get rid of the quotes. And now I go, what are you doing? Oh, that's in a search. The evil search engine grabbed my system. Okay, so here now we have, just purely in a web browser, we have deployed this this manipulate, and we can go and manipulate it. And every time we move the manipulate, it's going to do a server transaction, but we'll get the same result. Okay, we can also deploy an API. There's a lot of richness in the APIs that we can deploy. We can also get the embed code to deploy the API function from. So for example, if I did an API function where I ask, show a country. Well, here, if I do a form page of this, show a country, let's say hash country, and then let's say flag image. And then let's say, I don't know, color negate the flag image, and then make that a function that is going to be returned as a JPEG. And then I'm going to show you, okay, so now I can say cloud publish that. And that will now make me a form that we can go to the web here. And now, oops, what did I just do wrong here? I said, what did I do wrong? Oh, I didn't need that. That's what I did wrong. Okay, so it asked me a country, so I say Peru, for example, and now it'll show me I don't know the Peruvian flag, but I bet it doesn't look like that. That's the color negated version of the Peruvian flag. Okay, now instead of form page, I can say make me an API function, and now I am going to have to say how it's going to return the result. So let's say a JPEG, and now I could say cloud publish that API function. Now I have something which, if I give it $country equals USA, for instance, it will now give me back to my web browser. It will return the JPEG there. But now, if I wanted to be more complicated, I could say, give me the embed code here. Now, this will not give the best result yet. Give me the embed code for Python. This, in the future, is going to give embed code that uses the modern Python client library, but it's a little bit more complicated here. But that allows you to access these things. Now, what's new in version? You're asking what's new in version 12 for all of this. Again, this is quite technical, but there's a bunch of new options for the way that API functions work and the way that cloud deployment works. In particular, yeah, I mean, this is kind of elaborate. I mean, this is all about how whether parameters are allowed to have extensions. And so what this is about is whether, if you say, for example, I'm going to give an API I don't know, a table of data, you will be able to say in the API, you'll be able to say, let's say the parameter is called X, you'll be able to say X underscore CSV, and then you'll be able to give the string that follows as a comma separated value string. Okay, so that's just part of the way that one deals with packaging an API to make it easier for other systems to access. So by the way, the Python Orphan Language combination is now already available. So let's see, expected consistent calculation speed from the cloud, or is it dependent on public load and on the server? I mean, it should be pretty consistent. It might depend on the load. If you really don't want it to depend on the load, get a private cloud. I mean, we have the ability to have a completely, let me show you an example. We have, let's see, again, I live very dangerously because I have no idea where this actually is. Oh, here we go. Enterprise private cloud. So, okay, you can get a complete private cloud, and this is how you install it on a VMware server configuration. As you can see, this is not, this is a serious piece of software engineering that you're installing here. But you can go ahead and just to give you a sense of how this works, this is the configuration of a private cloud, and it has there are many steps here that allow you to let's see, just to give you a sense of what's involved in configuring a private cloud. This is okay, we can just download the configuration notebook. That's fun. So this is if you wanted to get your very own private cloud. This is all the stuff you can set. So it says, okay, this is how to use the notebook. Of course, we're configuring everything using a notebook. This is how the domains work, nodes, web subdomains, mail settings, account settings, database administration, setting up the pool configurations for the Wolfram engine, et cetera, et cetera, et cetera. This is what you don't have to do if you're using the public cloud, but then you don't get your own sort of separate organization, branding, identity. You don't get to do things like call Python from within the language and so on. But if you want consistent computation speed, get a private cloud. That's a way to be able to achieve that. All right, so that's a little bit on sort of external interaction. Actually, I want to mention. I'm not sure. Let me just mention some things about Wolfram script, because I think that's something which is again new. It's been coming in progressively over the version 11 to 12 cycle. So Wolfram script is essentially, as the Python client library allows you to access the Wolfram engine from Python, Wolfram script allows you to access the Wolfram engine from a shell. Okay, and there are basically there are basically four ways to do that. So for instance, I could just say Wolfram script -code. Let me see what I can do here to demonstrate this. I would just put in, let's go here. Okay, so if I say Wolfram script -code 100 factorial, it's just going to run in my shell. It's going to run that Wolfram script command and get the result there. If I wanted to, just for fun, I could say Wolfram script -cloud -code 100 factorial, and now instead of running locally, it will run in the cloud. It has to have got my credentials to be able to access my cloud account, but then it will run in the cloud. So what we can also do is to run. We can run from an API that's in the cloud, or we can also run from a file, or we can run a function. Let me just show you an example of running a function, just to give you a sense of how this works. Let's see, I think there's probably an example here. Yeah, this is a function. So this is, you can have a Wolfram script file, a .wls file, Wolfram Language script file, and the first line of that file in typical Unix executable shell conventions is a hash bang, and then the path to find the Wolfram script. But then you can say -function, and then you give the function signature. And what this then does is it allows you to have a command line, a function which takes arguments on its command line, ingests those, and runs the Wolfram language code. So let me show you another thing that's new. This is a script notebook. So we've been able to have Wolfram language package file. This has been around for a little while. And so here we can write code. So I could write, code that says define a function, fib of x is x squared, something like this. This file, when I save this file, it will just be a text file. It'll be a pure Wolfram language code file. And if I put in things like section head here, that section head will just show up as a comment in the file, and it'll be recreated from as this Wolfram language script, Wolfram language package file if I wanted to. If I run something here, I can run it, and it will show up. The results will show up in this notebook, but those results will not be saved because this is really trying to save a script file. Okay, or save a Wolfram Language file. Now, there's another thing you can do, which is to use a Wolfram script. And so here we've got the hashbang Wolfram script, and it knows where in our layouts, it knows how to find that Wolfram script. And now you can write Wolfram script code, including something which defines a Wolfram script function and so on, in this file. And then you can save it out and then just run it directly in your shell. Okay, so that's a little bit more on sort of interfacing with the outside world. By the way, in a lot of things that a lot of conveniences that exist in version 12 that allow you to just sort of interact with the outside with your system. So system process data, kind of the analog of PS under Unix, that's showing me all the processes running on my computer, and I could start figuring out, I don't know, we could say, just for fun, we could just say, ag, let's say, all comma threads. Is that right? No, that's not right. I guess I just take that result and I say that all comma threads. I could look for a specific process here, but that's the thread counts for all the processes running on my computer. Let's make a histogram of those. That's the thread count being used there. Okay. Let me just talk a little bit about. There's a lot of things for dealing with remote files. So there's a whole notion of a remote file. So there's remote run. I don't know whether I'd be able to do this in a very useful way, but I might be able to. See if this works. This may not work in any useful way. Oh yeah, it did work. Well, I mean, it worked in the sense that what it is doing is it's running SSH, and it's going to allow me to connect to a remote computer, and then it's going to do computations from there. Okay, so anyway, that's but then you can manipulate remote files in a kind of convenient symbolic way. Okay, we're getting another question here about creating and deploying packages, also creating package documentation with the front end. Okay, I can show you one little sort of secret thing. It's not really secret, but because it's already in version 12, but it's not really, we're not yet really releasing it. I'm not going to go through this in detail, but one of the big things that's coming is our function repository. You can, let's see, let me just go, hold on one second here. I'm not, this is not really an announcement of this. This is, but I'm just going to show you roughly what this is. This is all stuff that works in, let's say, something like that. And now we can say, let's get that example. Well, actually, let's just get this function, hex string to real. And now what this will show up as is a resource function, hex string to real. So now we can say, I don't know what this is really doing, but something like this, and we can run it. Okay, now it's loading the code, and then it's going to actually do the computation. Okay, there it is. So what this is, so this is a new thing that everybody will be able to contribute to. Oh dear, it's saying my internet connection is unstable. That is a super bad sign. But then let me show you here how you make that contribution, because this will show you a bunch of things. So if I say new repository item, I say new function repository item. This is a very minimal thing that you fill out to create a new function. And what you'll see here is things like a tools button, and that allows you to create what looks like our documentation. So for example, here, if I say something like the hello function, and I've got argument X, and then I want to say subscripted variable, okay, X, I should have typed X sub 2, for example, here, and then I want to format that nicely. I can say template input, and it'll format it nicely, and all the kinds of things that you've come to expect from our documentation system. When you deploy this, which I'm not going to do this in great detail here, but when you deploy this, okay, I can say deploy it in a notebook, and that will now create for me it's complaining, right? It complained there because it's doing a pre-flight check on what I entered here, and it's saying name isn't set, description isn't set, it's going to do a bunch of other things. But what you see there is it created something which looks like our standard documentation. Okay, so that's all coming, and I mean, it already exists you can already do this in version 12.0, but we'll be releasing, really launching the function repository in a little while here. But this, I think, is a really, I mean, we've had internally an absurdly complicated system that has like thousands of complicated little buttons and so on to build documentation. We've got now the sort of minimal version of that does most of the things people need. Like it'll create if I wanted to, I could create let's see, I could insert a table with 3 columns. So I could go down here to documentation details, and I could say, just to show an example here, I could say insert a table with 3 columns. Okay, this will now be set up so that I can insert options documentation and so on. Okay, so that's a more or less a coming attraction here. All right, so let's go back to something else I was going to show, which is I'm going to show more about connecting to the outside world. All right, so one of the things we want to do is to be able to do reinforcement learning. And for reinforcement learning, you kind of need, if it's like a robot learning to pick something up, you kind of need the robot arm, and you need to see whether it successfully picked the thing up. And that is the thing that drives the reinforcement learning loop. So one thing that will be coming is reinforcement learning that goes through the whole system modeler stack. But one thing we can do before that is to use some of the existing kind of gyms that for that are simulations of the real world. So here's an example of a simulation of the real world. Let's see if this works. This should be something from the OpenAI gym. This is I thought that was a disease. What is that? Let me. I'm sorry. I have to do the I wonder what happens if I just if I do this. See whether that is anything that we recognize. No, it doesn't know what that is. I wonder, isn't that something? I thought that was some maybe I'm completely wrong and it's spelled differently or something like that. But I thought that was a thing out in the world. I guess not. Okay, so this is something anyway in this gym. And what can we do here? Well, let's say we do a device read. What this thing here is a video game. So this is actually going to be something where we can say, let us go ahead and look at the observed state of this video game. So it's represented by a numeric array. We can do a device read, and there it is. And this thing, so that's an image that comes from this simulated video game that's running inside an external library that represents this game. So for example, here, if I wanted to, I could do, I could start analyzing this. I could say edge detect this, and I could do all those kinds of things. But I can also actually run the game. So for example, I could say, give me, for example, let's do this. So if the game ends, just return. Otherwise, let's just try giving me like 10 successive states of the game. Okay, so probably that little guy is moving around in the game here, and this is with a random action. So what we could do here, let's get 100 states of the game, and let's go ahead and make a feature space plot and see if we can sort of recognize what's happening in the game by making these random moves and then seeing how the game behaves. Okay, so what we learnt, I don't really know what's going on here at all, but probably these represent different kinds of states of the game that, and maybe what this is showing us is possibly, this is a corner of the game, this is a corner of the game. I mean, what we could also do here is actually, I'm going to do one thing just for fun that I think might be kind of interesting, is if I take these game states, let's take 100 game states and let us do, let's, yes, Edmund is again telling me Montezuma's Revenge. Let's see, or Montezuma Revenge. Let's try it just to Wolfram Alpha. Oh, I thought so. I thought so. We just don't have, we don't yet have, there's another piece of data that we don't yet have fully flowed into Wolfram Language. Okay. Yeah, it's one of those things you don't want to get. But I guess in this video game, I don't think that's about this in the video game. I think it's something completely different. I think there's a dude called Montezuma in the video game, who was somebody else, right? Wasn't that, I'm going to show my lack of knowledge of history, wasn't that like an Incan something or other? Oh, I'm probably going to embarrass myself. Yeah, Montezuma the First. Okay. Oh, Aztec. My apologies. Okay. Okay. So that was probably the original Aztec. But let me go ahead and make this table here, and then what I'm going to do is I'm going to say, yeah, this is an interesting idea. So I'm going to get these 100 game states, and then what I'm going to do is I'm going to say, make a nearest neighbor graph with those, with just, I see. Okay, so that's showing which of these is nearest neighbor with, let's say, vertex labels, arrow automatic. So what this should do, oh shoot, this was, I needed to tell it, well here, let me just make it really, really big. I should have been telling it to use a smaller, I have to tell it to use, I think is there a vertex label size? Vertex size, let's try that. Let's say 0.05. And now I shouldn't be using percents. At least one of my children is always telling me, don't use percents in these things. It'll get you in trouble. And one should learn from one's children. Okay. Oh, that didn't work. I think I have to tell it. I have to set this up slightly differently. But my goal here was to kind of show. All right, let me just try one thing here. If I just try kind of the simple-minded thing, let me just try maximizing that window, and then make that a lot bigger. Okay, here we go. So this is now going to be showing me essentially which game states are neighbors in the sense of having a small visual distance. So actually, it's kind of interesting because you can see along here the dude, perhaps it's Mr. Montezuma himself, is has a sort of continuous change as we go through through this sort of reconstructed sequence of game elements. Okay. So anyway, we can then put this in a loop with our machine learning system to start doing reinforcement learning using this kind of external source of kind of external virtual world. Okay, talking of virtual worlds, let me try and show you something more challenging. One of the things that we've added in version 12 is the ability to communicate with microcontrollers. So if you thought there were a lot of computers in the world, there are an awful lot more microcontrollers in the world than there are computers. A typical car has like 30 of them or something. And what this is about is being able to take code that has been created in Orphan Language and actually download it to directly to a microcontroller so that it can run autonomously in the microcontroller. Okay, so we have here, I don't know, let's say control the speed of a stepper motor. Okay, so these are actual projects in the documentation where you actually need little hardware devices to do them, because we're actually downloading things to the device. Now I should have, let me see if I have this here, see if this works. I should have on my desk here, I hope. Yeah, there we go. Okay, I have a little Arduino on my desk, and this is just a camera. I mean, I could use image capture here if I really wanted to use our tech for everything. But let me not do that, because I'm going to use this. I'm going to use this to actually control the microcontroller, and I want to show you this separately. Okay, so there is my little Arduino. Here it is. And this is connected to a port on my computer. And what I should be able to do is to take something like a filter, and let's see whether I can do this. This is a filter. It will be it'll have a certain response. Now, if I wanted to, I could take that filter and let me load in the microcontroller kit. And what it should do, and it knows about many, many different kinds of microcontrollers here. So what we should be able to do here is to say microcontroller embed code. So this is now saying create code that can implement that filter running in the microcontroller. That will be runnable in the microcontroller. Okay, there we go. And now we could look. Okay, the source code byte count is 3227. So I think I could actually look at that code if I wanted to. Let me see if I can. And hold on one second. If I say, here we go. All right, so I want to say that the source code there. So I say source code. I don't know what this is going to look like at all, but this is code that has been created, was just created right now for, that is in some kind of Arduino C, and that's been created to run that filter directly in the, I don't know, this looks kind of complicated, but that is going to run that filter in the Arduino Uno device that is connected to /dev/USB modem, whatever, which I happen to know is the port that I plug that thing into. Okay, so let's go back here. I don't know if it's going to show anything when I do this, but let me go ahead and say I want to, let's see, I want to actually run this in the microcontroller. You know what, I was going to try and get this to flash a light. Let me see whether I can do that. Let's see, do we have something that will do that? Hold on one second. You know what, I think I may be failing at this. I think, let me take a look here. Yeah, I think I may not be able to do this. Well, maybe this will. Okay, let's try this. Okay. So this should be able to, let's see, machine code. Oh yeah, embedded to target. So that means source code was created. So microcontroller embed code actually sends this code to my microcontroller. So in principle, let's see if this works. This apparently is going to do something here. Let's see if this actually does anything. Okay, wake up, it's creating the code. And look at that, amazing. All that technology, and it blinks an LED. Isn't that cool? I don't know how cool it is, but at least it shows it does something. And let's just to prove that this isn't a total fake, let's make the sampling period 0.2, and let's re-download new code here, and let's see whether this does something different. Yeah, look at that. And now if we wanted to be a little fancier, we could start like writing something which would spontaneously do do something in the microcontroller. Now, in principle, what it should be the case is if I unplugged it The important point is that code is now resident in the microcontroller, so it will keep doing this forever. It doesn't need to be connected to Wolfram Language. Unfortunately, if I unplug this, it's not going to have any power, so it's not going to be able to keep doing this. But assuming I had a battery on here, I would be able to keep this going for as long as the battery lasts. So anyway, that's another new capability, is being able to create, and this is important for building actual devices in the world. That's that. Okay, talking of external connections, actually I have to. This thing is flashing on my desk. I have to download something else to just stop it flashing here. The talking of external connections, another big one is a connection to the Unity game engine. And so let me try and show you that. Again, these things are, that's something we've been working on for quite a while, and I should be able to show you that. Okay, so let's say I say needs Unity link, and now I have to start Unity. Okay, this is good, it's started here. And now I should be able to say Unity open. Let's just do this. Let's do this. Unity open, new project. Okay, what's going to happen here? So something should be happening, I hope. Okay, opening Unity. Okay, let's see what happens. It's running, it's running, it's running. Let's see if Unity, oh, I hope this works. This is not, whatever's going on here is not our fault. That's the Unity system trying to open itself. It made a beep. That is a bad sign. I wonder what that is. Looks like another Unity instance is running with this project open. Fatal error. Oh my gosh. Unity bug reporter system. That's not a good sign. Okay, I think what happened is that I already had something named new project. So what I want to do here is Unity quit unexpectedly. Ignore that. Oh my gosh, this is a big, horrible disaster. Okay, let's load Unity again, and let me say new project, let's say new project 102. And then there's a decent chance that that doesn't already exist, and it won't crash Unity, and it will just start up. So let's try this. Okay, Unity is hopefully starting. What is going on here? Why is Unity downloading a new version or something? Wow, what's happening here? Oh, Unity is starting. Okay. Unity is, oh, come on, reserializing assets. Okay. I'm always upset by our startup speed, but we're a lot faster than this. Let's see. Okay. No, I don't need a new version right now. Stop. Don't do this to me. I don't need a new version. Okay. Sorry, we also have a question on the live stream about, can you import microcontroller code into a system model object and simulate it? That is a really good question. You can take the symbolic thing that we send to the microcontroller, and you can insert that in a system modeler system. I don't know if you can take the microcontroller code data and do this. Actually, okay, hold on 1 second. Let's show you something here. Actually, you can. So I guess this is an example where you can, what is this doing? This is taking, use the microcontroller kit to generate automated code and deploy it to a microcontroller. Okay, all right, okay. Yes, so you can deploy and test a PID controller directly through System Modeler. That's pretty cool. Okay, back to the game engine. Okay, so we've got now our new project. So now what we want to do is to take, let's make a, let's get our typical, I don't know, so let's take a dodecahedron, and let's say augmented polyhedron of that, comma 2 or something. Let's see what that does. Okay, let's make a graphics 3D of that just to see what it is. Okay, there we go. And now let's say create Unity game object. Okay, and now we're going to have to name this object. So let's call it star thing. And now let us try just inserting that into the game. Okay, so that should have inserted an object. There we go. Okay, so now within our Unity system, we have that object and we can do things with it. But if we wanted to, we could, so for instance, we now have, if I look at what we are able to do there, I can't do any of it, but we can write directly in Wolfram Language a, let me try and show you this. So within Wolfram Language, we have really deep access to Unity. So we can control Unity from within the language. So here are things where we're saying do operations on these Unity elements. So for example, you see here, just a lot of stuff. Create Unity lens flare or run a Unity particle system. All of these things are symbolically doable in Wolfram Language. And so this is, so you can basically control your game. You can write all the control for your game. In fact, you can write the game in Wolfram Language and then deploy it to Unity. You can also, from within Unity, you can call Wolfram Language. In addition, within Unity, you can see how the game is being played and essentially send telemetry to Wolfram Language that you can analyze later. So I had an example here of a particular, let's see, I have this in the cloud. This is a, let's just download it so we can play around with it. This is a virtual piano that should be written in terms of Unity. So there's the keyboard that we're trying to make, and that's, oh my gosh, that's a complicated piece of code there. But the main thing that we want to do here is, okay, and that this thing actually has notes that we play, and so we can then say create the piano keyboard here. So now we're using our 3D geometry here to create the keyboard, and then actually I've got to run all this stuff. Then I'm going to build the piano simulator. And so that involves actually opening things in Unity and doing operations on them. And now that's, this is kind of a computational essay about game design that shows you what to do. And at the end of it, eventually, we will have we'll have built the piano in Unity, which we can then play. So what this is doing is essentially showing you, if you're interested in game design, for instance, or you're this is showing you sort of the complete game design, and you can also use this to do things where you have sort of defined everything in Wolfram Language, but now you want to sort of deploy in Unity. Okay, well. So that's another big thing that's come in version 12. All right, we're getting closer to the end, I would say here. And let me mention a few other things. For people who are interested in, this is going to be unfortunately a somewhat undemoable thing, but for people who are interested in financial data, we now have the ability to connect, and this is, I'm afraid, is simply not going to work. I think for me, it's going to require authentication against the Bloomberg terminal, and right, this is something available in our Wolfram Finance platform, and this is allowing direct connection to Bloomberg and Reuters financial data feeds, and let's see, I should have documentation at least here. This is, okay, so the Bloomberg terminal here, this is, so there's a whole authentication mechanism, but once you're in there, you can you can use all the capabilities of the Bloomberg terminal directly from within Wolfram Language, And and again, this is quite technical, but one issue is you can, for example, get a continuous feed. You can continuously ask for data, so you can have a continuous update of financial data. And there's also this new function, service submit, that allows you to submit an asynchronous function that will then, whenever it receives a market data event, it will then call a function to do what you want it to do. Okay, so so that's another new thing. All right, some other things to mention. Well, there's a lot of new stuff sort of under the hood, with lots of enhancements and so on, lots of things that go faster, lots of things more robust. The Mac front end is now fully 64-bit. That was a big piece of software engineering to achieve that. The Windows front end still does not have high DPI support, but that will be coming really soon. And also something that's coming actually in the next couple of weeks is yet more enhancement of the cloud, and particularly getting closer and closer to being able to have notebooks that are a really clean notebook publishing model. I mean, basically our model is anybody can publish a notebook to the cloud, and they can have the notebook be active in the sense that manipulates and things will run in the cloud. And then anybody who goes to that notebook in the cloud can read it there, and they can press a button that says make your own copy. Then they'll get a copy in a basic cloud account, a basic free cloud account that will allow them to do a certain amount of editing and computation. If they really want to get serious, then they've got to get a real account. But they can at least do basic computations in our cloud basic system, which you'll be able to get from any from any published notebook. So that's the thing that's coming soon. All right, I think I've pretty much, I don't think I've really covered everything, but I've at least tried to give some indications of some of the things that are new in version 12.0. That's kind of a word cloud of oops, I clicked the word cloud. Oh dear, that's a clickable word cloud. I was thinking I was going to be able to expand that word cloud and show it to you guys, but that's okay. There we go. But it seems to be clickable, so I can't. Okay. Well, if you have questions, I'd be happy to try and address them. Take a few minutes here to. I've gone through a bunch of functionality. I think some of the stuff towards the end here has involved sort of deeper software engineering than some of the earlier things. But I'm open for questions. The cloud has been flaky lately. That's sad to hear. I have no comment on that. I mean, it's a pretty big system that is pretty well monitored. You know, it should be quite stable and quite robust. I mean, things can happen. You know, you're communicating with it through the internet, and you know, that's always a risky business. If you have a private cloud, you don't need that, but with the public cloud, that's that's what that happens. So let's see. The next question. Yeah. By the way, if you do see something flaky in the cloud, send mail to support@wolfram.com. Oh, the iOS app, from using the Wolfram Cloud from the iOS app. That's an interesting question. I don't know. I know there's a new version of the iOS app that is just about to be deployed. I should just show. I can show people perhaps. There, I can just get out my phone, and this is a fun thing to do. Since I happen to have the camera connected here, let me just for fun, I could say, okay, let's get rid of the Arduino. Out goes the Arduino. In goes the phone. Oops! Oh, bad idea. I've got to put it on a piece of white paper, otherwise the thing doesn't see it properly. Okay, and now if I want to, I can go here and I can say create new notebook. And actually, this is I have found that this is if I say make an input cell, all right, now I'm going to start well, that's bad. That's okay. Now I'm going to start typing here. So I say something like plot, and now I get an autocomplete here. Now I can say, show me, this is a new thing. Show me a template here. So now it's going to say, there's a template for the plots. I don't have to do as much typing. So now I just click in that first place and I start typing there. What do I do to start typing? See, this isn't a good sign, is it? What is happening here? I should be able to just go there and say I want to type, I think. That's why we need a new version of this app. And I'm afraid I'm having to confirm your claim that this is slightly flaky. So I think there's a new version of the app that will be going through the App Store momentarily. I think there've been some issues in that app going through the App Store, but that should be happening very soon. It's a shame I can't. This usually works just fine. I'm really surprised that this is not performing well. Oh, well, anyway, this is, by the way, that's running against the cloud. I might just mention to you that there is also Wolfram Player, which is something which is actually running locally on the phone. So this does not allow you to edit, but this is something where locally on the phone you can. So for example, when somebody emails me a notebook and I open it on my phone, I can now open it on my phone with the Wolfram Player app. And this is a bad. Let me go back to the default magnification. Okay, so and this is pretty convenient because I can run manipulates and things because there's a full kernel running right here on the phone, and I can rotate things around and so on. I can't edit here, but I can. It's very convenient to be able to read notebooks and things directly on the phone. Let's see. Question: is there a schedule to keep track of for live streams? So there are two categories of live streams that are going to be happening. One is presentations by the actual developers of all of these features, and somebody can perhaps tell me where that live stream schedule is going to show up. I'm not sure. Okay, the next question here was, will there be a bugs entity store? That's actually an interesting idea for how to expose this. I mean, we obviously we have an internal bugs database. Obviously, we have had for 30 years. It's a question of and we could expose it. I don't think it's as useful to people as one would like it to be. I would say, by the way, that our we can actually connect to the bugs database using the I might it's too fiddly for me to do that right now, but using the whole relational database symbolic access system, we can connect to our own bugs database. And the question of how we expose that, good question. People are asking for this. We don't have anything to hide particularly, and we're happy to expose it. It's just a question of making something that's even vaguely useful to people. Okay, let's see. When is the Packlet repository coming? Actively being worked on. The function repository, which is a much simpler in terms of a function repository, is purely you've got one function, you provide it to the function repository, everybody can use that one function. That will be coming within a matter of weeks. The Packlet repository is further away. That's more complicated because a Packlet is defining this whole sort of world that you have to live inside, and that's just a more difficult thing to set up. User interface question: in version 12, why did the magnification move from the bottom to the top? Because that's part of the new Mac interface standards, and there is something else that's needed at the bottom. I've forgotten what it is, but it's part of the new, and we're now using the whole Cocoa system on the Mac, so that you're able to interface with all the sort of cool Mac gadgets and so on directly from our interface. Are emojis finally available? Emojis are partly available. The main issue with emojis is being able to have, being able to deal with Unicode that goes beyond plain zero Unicode. You know, when originally there's 65,000 characters in Unicode, a few things like, I don't know, Babylonian cuneiform didn't make it into plain zero Unicode, the first 65,000 characters. It's in plain one. And to support that, one goes to beyond 16-bit Unicode, and we have that support now. That support is slowly coming to different parts of the system. It's complicated to do that. I think I could show you an emoji. Let's see, how do I do that? If I just say, how do we get an emoji? Let's see. This is one of these things. I've got to learn. This is for. Is that right? Is that no? That's very amusing, but hardly the point. Let's just. This should be showing me. Okay, a glass is smiley, but what's the Unicode for that? That's actually something we should add to Wolfram Alpha, is what the Unicode value for that actually is. But then I could dive into Unicode, Unicode 150,000 or something. I don't have any idea. Oh, what was that? Why did that work? That shouldn't have worked. Why did that work? Maybe, that one. Okay, that doesn't work because that's outside of the Unicode zone that we can display. But we can handle emojis in strings now. We just can't handle them in the desktop front end. Actually, they will come to the cloud front end before they come to the desktop front end. Surprisingly complicated to deal with. Notice the input screen didn't come up right. That's part of the problem. Yes. Right. Okay. Basically the status, maybe somebody can let me know here from the internal team what the ETA for the new iOS app. I think it's a matter of days. I think it's in the queue, but it's had some issues with approval in the App Store and so on. Okay, there we go. Look at that. There is an actual emoji now, and presumably I can take that emoji and I could do this is where things go wrong. Yes, I can't copy paste that emoji, but I can take that emoji, and that is that's a bona fide emoji. And I bet if I change this, I was entering it in. Oh my gosh, no. I was entering it in hex here, so. Let's do something like this. Let's just change that to 0 and see if that's another emoji. Oops, what did I do wrong here? What did I do wrong? 30. Oh my gosh, that is because I had pasted an emoji in there. Okay. Oh my gosh. Well, that's a pair of emoji and it's very confused. But I can start doing computations here. I think if I take that first emoji that I had, then I should be able to say from that to character code of that thing, and it'll give me the character code and so on. So emoji computation is starting, but emoji display is still a little bit, that'll be a 12.1 feature. Okay, any plan for local deploy to have like the cloud deploy, but locally hosted? Okay, so yes, there are several plans for that. So there is a mechanism. You can actually start a web server locally on your computer and connect code to it. We don't consider that a really that is really a deep developer style piece of functionality. It either is now or will soon be on GitHub, the Start Web Server functionality that allows you to do that. Second thing that's happening is an application server where you can install a web engine on your computer, and it will accept HTTP requests and so on. It will not run notebooks, but it will run APIs and so on. Third thing that's happening is a Wolfram, Wolfram Web Engine library for various kinds of wrappers that allow you to access, basically glue a Wolfram engine into a web server that is being run through Java or Python or something. Okay, so those are coming soon. Let's see. Yeah, by the way, the live streams you can get to from twitch.tv/Wolfram. Yeah, so okay, so that's that. Now, in terms of local deploy, let me show you something else that actually is new in 12, and I forgot to mention it. This is a okay, this is, again, I'm afraid this is complicated stuff. This is the notion of session submit. Okay, so we actually have let me explain these things. Cloud submit, session submit, local submit, cloud submit. This is for handling asynchronous tasks. So, for example, if I say, let me try this. So if I say cloud submit, so let's try doing this. Let's try going to the cloud. Well, here, let's do this. Let's say, let me then explain what this is doing. Okay, so what this is going to do is it's going to, let me do this. Let me run. Yeah, so what this is doing is it is creating a task that will run in the cloud. And what the heck? Oh, I see what that's doing. Oh my gosh, how confusing. Okay, that task computed the expression now, which gives the current date. It ran that, it submitted that to run in the cloud. That ran asynchronously in the cloud. But what I told it to do was to have a handler that when the task is finished, it puts up a message dialog with the result. Okay? So this is now running, it's specifying run this asynchronously in the cloud. So for example, this could take, an hour to run in the cloud. You can run that asynchronously, but when it's finished, when some other event occurs, so that's not the only possible event. So for example, in cloud submit, there are other events, like for example, message generated or failure occurred. And these other events are things that you can trigger on to perform an action that you then see. Okay, so that's cloud submit. That allows you to submit asynchronous operations to run in the cloud. Now you can do the same thing locally, but what happens in local submit is, so we could do the same deal here. We could say local submit. What this will do is it will start a local kernel, and it will start a separate local kernel in which it will run this task, and then it will call back. When that task is finished, it will call back to my local kernel here, my original kernel, to perform this action, which in this case puts up a message dialog. Okay, the third and most exotic of these is session submit. And session submit actually submits a task that will be performed during this session. Okay, so let's see what happens here. If I put this message dialog here, and I session submit that. So, okay, so what this will be doing, this is running inside my local session asynchronously. And what it will do is it will try and steal time away from my local session. So for example, if it sees my local session is waiting for an input, then it will go run those asynchronous tasks in the local session, in the local kernel that is actually connected to this notebook. It will run those tasks and asynchronously produce the results, calling back through this handler mechanism to do what it does. So those are things you can do if you want kind of so for example, local submit is a way to start another asynchronous task on the local machine. Let's see. Okay. Let's see. A question here is, we have a function that creates a 3D reconstruction via manipulating a focus stack of images. Can one obtain specific coordinates from the 3D plot, giving the coordinates, the XYZ coordinates in plot space? So let's see. I think what you're talking about here is, well, let's just see. I'm going to have to image processing here, and so this is going to be in the B. I think, is that an image restoration, or is that in? Let's see. It's basically a computational photography function. I think. Let's try taking a look here. Oops. Okay, so in computational photography, which I don't know that much about, this is combine images. So here, let's see what we're doing here. So this is a way of combining images to make a sharper image. Now, what you're saying is, you obtain specific 3D coordinates from the plot. The answer, I'm afraid, is that I don't know. If you tune in to one of the live streams about image processing, then you'll get a real expert in that. And I think there may also be some office hours about image processing, and that would be another good place to ask that question, or ask the technical support folk. I do not know the immediate answer. Okay, a comment from Durbo on the live stream. The web server, the start web server version is a toy that's in, and I agree. The production ready version is coming soon. Okay. Okay, here's a request to make the Untitled One startup window size and position be persistent from launch to launch. Okay, here's the problem with that. We don't know what computer you're on. And the only thing we could know is, well, we don't know, I'm sorry, we don't know what monitor you're on. We could guess that if you're on a monitor of the same size that you were on before, that you want the same configuration. I actually thought it did remember this, but you know what? If it doesn't, we should remember that, because we now have another thing that I didn't even mention that's new in version 12, is the whole persistent value mechanism. And so persistent value is a way of storing values persistently across a variety of different levels of, okay, so persistence location can say, I want to store this value for a particular kernel session, for a particular front end session, on a particular server, on my local computer, but shared, or in the cloud. So if I store it in the cloud, I would get that same persistent value wherever I start Wolfram Language. But yeah, I don't actually know what the story is with. I actually thought it was sticky, so I'm confused by that. We can try and get an answer separately. Let's see. The question, API function cannot access HTTP request body when used with the URL dispatcher. That's getting fairly technical. Just to give just for other people's benefit, this is pretty technical. This is what happens. URL dispatcher is a way of being able to basically build a sort of a website that can deal with dispatching to different places, dispatching a web request to different places depending on the form of the URL. I'd actually be curious for people if anybody knows about GraphQL and whether people care about GraphQL. GraphQL provides a sort of a specification language for more elaborate kinds of ways of setting up web APIs. Let's see, any prospects for better GPU support for neural nets on Macs? This is a question about NVIDIA support on the Mac. Yeah, this is a complicated story. I mean, our underlying library that we use for low-level neural network operations is MXNet. MXNet and TensorFlow are sort of the two big low-level libraries. We will probably eventually support TensorFlow as well. We chose MXNet because it was faster, and then the question is really, how does MXNet get supported by the low-level hardware? And we've been big contributors to the MXNet open source project, but there's also components of it that need to be contributed by hardware manufacturers and by system manufacturers, so that all of these things flow correctly. I'm actually really surprised that with all the different things that I can't speak to Apple's internal priorities, but I'm really surprised that we haven't seen MXNet running really well on Macs up to this point, particularly since that's the Apple has said that's there's lots of Apple contribution to MXNet. So I'm really surprised that hasn't happened yet, and I'm sort of hoping it will happen soon. I would say in terms of GPUs, the thing we have in version 12 is multi-GPU training through NetTrain. So if you have access to a machine with multiple GPUs, either locally or in let's say AWS, you will be able to make use of those multiple GPUs for neural network training. That's kind of a big deal, and that's made possible by the very latest innovations in MXNet and so on. So let's see. In terms of GPUs, I mentioned one more thing, which is with our new compiler, we have a serious chance to be able to actually generate GPU code that can then be run. I mean, GPUs are a complicated story because GPUs they don't run operating systems. So you kind of have to know, you have to have something that's controlling what's actually going into the GPU, and you have to be kind of ready to manage the sort of ambient computation environment around the GPU. But we will, the compiler, we expect, will be able to do a very nice job of generating native GPU code. I see a comment from the live stream that GraphQL is great. Well, we have looked into it, so please let us know if you have specific suggestions about it, because it's kind of on the slow burn at this time. But we'd be interested to know if we should accelerate it and what the particular use cases for it are. I mean, essentially, API design. I've spent it's now nearly 4 decades doing language design. And one feature of language design is things get to nest in language design. You have a function that eats the results of another function that can be eaten by another function, and so on. And that kind of nested structure imposes certain kind of coherence in the design if you want to do it well. In APIs, the traditional design has just been, it's a bunch of keys and values. And that's kind of any API, just sort of it's a stream of keys and values. And if it doesn't fit in keys and values, then you've got a problem. You have to kind of pack it into a big lump of JSON or something to feed to the API, and it's kind of a bit of a mess. I think one of the potentials of GraphQL is to give one a way to start having a different kind of design for APIs that has a bit more structure in it, and not quite to the level of an expression, but something a little closer to that. Let's see. Somebody commenting. I should have mentioned. I was talking about live streams. I should have mentioned that in addition to the very organized live streams from a bunch of developers, we also do quite a lot of live streaming of our internal design meetings. And we've had a little bit of a hiatus about that because when version 12 was being finished, we don't really want to do new designs because it's all hands on deck fixing bugs and getting the release ready to go out and creating examples to show people what's in the release and all those kinds of things. So we had sort of a hiatus in our live streams for design reviews, but those will be picking up in the next the next week or so, and we'll be talking about features for future versions of Wolfram Language. And I encourage people to tune in. It's hope people find it interesting to see what's actually involved in figuring out language design, and we certainly find it useful to get a lot of good comments. In fact, in version 12, for the first time, we have actual design decisions that were significantly informed by comments that people made and suggestions that people made in live streams. So that's kind of cool, and we really appreciate it. Let's see. Let's see. What's the best place to report use cases and design ideas? The best place is probably send mail to outreach@wolfram.com. The thing that's complicated is every one of those suggestions has to go, has to get triaged through all the different groups at our company and so on. So it kind of needs one central place. In Wolfram Alpha, by the way, if you're using Wolfram Alpha and you see something wrong, please fill out one of those feedback forms at the bottom. We will read it. You will get a response. It's super useful. And some of the things like, you claim there's a mountain in my backyard that has such and such a feature, and I can see it and it doesn't. We really need to know those things, because that's the only way we can fix all the little data issues and so on, and really encourage people to use the feedback in Wolfram Alpha. We actually do have a feedback mechanism in Wolfram Language, although I don't really like the way it works. Actually, we're probably going to have a function called send feedback that I think will be coming in version 12.1. Actually, I'm a little surprised it isn't here in 12.0 now that I think about it. And that will be a nice way to just take what you have in the language in a notebook and package it up to send it in. I'm reminded here that there is actually a function that I think people will really like, which is the synthesize missing values function. It's a new machine learning function, and that name was suggested by someone in one of our live streams. So that's much appreciated. I might mention. I will mention just one more thing, which we're not really advertising as a new feature of version 12 because I consider it way too experimental. This is our chat system. So we have, going through the channel broker, we have a chat that you can run that will, and I'm going to try just, let's see, I'm going to just try sending this to a couple of people just to show you how this works. I am going to create a chat session here, and participants are invited after my first message. So if I say here, hello everyone, this will make a chat session that hopefully will invite some people. Let's see whether anybody is paying attention here and can be invited. But now I could, if I wanted to, I could put an input cell here, and I could send a little manipulate here, and then that will come out on my recipient's system. So if I send that, that will arrive in somebody's chat, and the people I've invited to chat with me in their chat session. So one of the use cases here that we anticipate is, for example, for education purposes, being able to have people in a class, for example, send in results, being able to distribute code that people can run immediately, those kinds of things. There are other mechanisms to do that through the cloud, but this is a convenient way to do it. Okay, bad sign. Seems like this didn't actually invite the people it should have invited. Well, that's why it's experimental. All right. Well, if nobody has any other questions, we should call it a night. And much appreciate your coming to see this. And hope you have a great time with version 12. And please join the live streams. Give us comments. Make incredible things with Wolfram Language. That's always a fantastic pleasure to see. So thanks a lot and good night.